All right, thanks everybody for coming to the session. And actually, Leslie, if you could capture who is here, I'd appreciate that, because that's something that I don't think I'm going to be able to do in real time.
Will do.
With 31 participants, that's great. So let me start off a little bit with the background for this. First off, title, I really intended this to mean future Keck IR spectroscopy, not so much near IR. That has different connotations to different people, but I'm thinking about out to like our traditional 5 micron kind of wavelengths. I know that some, it's different in different communities. So I've got a slide here on the purpose. So I was talking with, I should go back and say, so my name's Tom Green. I'm at NASA Ames. I'm also a longtime member of the Keck Science Steering Committee. We've had a lot of interest in new instruments in infrared spectroscopy. We've had a lot of upgrades. We've had new instruments. This is a booming area. Keck is very well situated to do well. It has done well. MOSFire is turning out great science. NIRES is a fantastic wavelength range. NIRSpec has been a real workhorse, and I know I'm forgetting one, but we have a lot of great instruments, and a number of great, Osiris is the workhorse AO one. We've had a lot of new instrument ideas come through the Science Steering Committee. Been very impressed. A lot of these have been leveraged by other observatories, TMT, Arizona, other ones, and Texas. And we've given our blessings. We really want these to prosper. And but there may still be gaps, and thought that it might be good to get a little more community input in general about what the community wants. Be able to, this info could go to the current instrument developers, and also maybe identify what is missing, and to be able to give opportunity for new people. And we have a new plan coming up. So what I'd like to do here is talk about a workshop to do all this, and would like to use you folks who are joining to help with that, ideas and organizing. And also would like to present briefly the instrument concepts and proposals that are going forward that the Science Steering Committee has endorsed and Keck Observatory is supporting. And what I really like everybody at Keck with an interest in infrared spectroscopy to participate in this. Any questions about this session? All right, I'll move on without hearing any. So we're going to focus on planning a workshop, and the idea is this would be like a one-day thing. And I put up some goals here about assessing Keck community interest, and fostering communication between the community and instrument developers, and then have a I'm looking at sort of an outline style report, not too much prose, to the Science Steering Committee, and also to Keck, particularly if any opportunities for upgrades come up. And also this should inform the next Keck strategic plan. A strategic plan is done every 5 years. The last one was done in 2016, so it's coming up. And you instrument developers have probably, noticed the calls for white paper saying that your ideas should, be referenced in the plan. So this is an opportunity to get stuff into the next one. And just a few more details about this workshop. I mentioned being able to solicit and compile input on capabilities from the community, be able to inform the community about the new instrument concepts that are going forward, and provide, information that the teams can use as feedback. There might be some science uses for your instruments that your own science teams hadn't fully exploited that you could use as ammunition. So hopefully you'll be able to actually benefit from any community input in going forward into your proposals, and just to build a bigger base for doing science with your instrument concepts. And then also identify new capabilities and upgrades to meet needs. You know, and this could play into the call that comes out every spring for Keck white paper ideas. And then produce a report that's going to, again, just kind of, I'm looking at outlines, tables would be nice to inform strategic planning. Probably won't be too widely circulated, but would like everybody's you know, consensus on what's in it, everybody that participates in the workshop. Another thing this might be used for, I'm not sure, is that the SSC gets a lot of one-off, sometimes we get one-off requests, and also not only do we get asked for endorsements for instruments, we get asked for assigning nights, and you know, some idea of how much something's supported by the community, you know, might be used in that. I mean, I don't know, I don't make the rules, but just thought the information could be useful. All right, questions about the workshop? You're all very quiet, or else my audio is dead.
It's Leslie Young. What's the approximate time frame you were thinking of for this?
Yeah, that's a good question. So I initially thought about having it in October or so, and just to kind of keep it on, so make sure that it happened on some kind of radar. It's not a really hard deadline for that. I'm going to be preoccupied with James Webb proposals in November. I know the instrument builders are working on NSF proposals for November. I've got some NASA proposals for December. I have to run another workshop in December. So it seemed to me for that late October might, if, you know, but, you know, we can't have a workshop with one person. So it's got to work for everybody. So that's going to be one of the things to talk about today is when would be a good time for this.
So Tom, it's Chaz.
Yeah, Chaz.
I guess I'm wondering, are you seeing this being a conference, a by invitation only? Do you see 10 people, 20 people? You know, how do you apportion between, you know, directly inside the Keck community, you know, in the instrument builders, or, you know, science areas and so on? I mean,
well, what I was thinking that people have to show enough interest to complete a form. And I've got a draft one of those. I can show it later, but I was thinking that people need to be interested enough to it'd be good to give, if they'd want to give their scientific needs, or else would want to partake of this because of their instrument connections. So I don't know what that really translates to in terms of total numbers. I'd imagine that I'd like to pick a more select group to help with editing the you know, the final report. Would like to get comments from everybody. I think input is good, but you may need to restrict the number of chefs that are actually you know, making the soup. And do you have any suggestions there, Chaz?
yeah, I mean, to me, there's sort of a two-dimensional, probably three-dimensional matrix. I mean, there's the science goals, which are, you know, extragalactic faint things. Then there's galactic things, or, you know, more nearby extragalactic things. Then exoplanets and solar system. You know, we need representation, you know, from all of those, and we'd want to make sure that there's at least, you know, one or two people in each of those columns. And then as rows, you know, there's what wavelengths do you want, what field of view do you want, what, you know, are you diffraction, do you want diffraction limited or wide field of view? And of course, you know, what's the resolution? I see Mike Muma there just saying 100,000 at 5 microns. Thank you very much.
Gosh, why did you think I'd say that? Actually, you raise a number of very important issues, and obviously, when you're looking at very faint distant objects like extragalactic and so on, that requires a different class of resolving power. than, for example, something that's bright and nearby. So I think many of the, as you know, many of the recently approved or developed instruments tend to, I would say, go for wide spectral grasp versus high resolution. So there's some real serious trade-offs that, and the slit length is the other one, of course, extended versus point sources.
Right.
Yeah. Yeah, I think those are all the kind of details we need to hash out at the workshop. So what I was thinking about, and John O'Meara agreed to like send out an announcement of the workshop along with a form for people to express their science needs and also indicate whether they wanted to attend. This is like a draft version of it. And so like you're saying, Chaz, you know, it's like, let's say asking people to put in like, put in science needs, different science categories there, with the description of the case, what capabilities are most important for that, what instruments do you currently use, how do you want them improved, and which new instrument concepts, you know, et cetera, and just get some demographic information. And I was also thinking, yeah, so we should get the, I was thinking about getting the results of this workshop in advance of the meeting. Sorry, the results of this survey in advance of the meeting, and then going through it with some people and having maybe a few science speakers, for example, like that could help kind of give a big picture thing, you know. So you're certainly in danger of, you know, getting asked to do exoplanets, and then, you know, somebody, and maybe also look at SSC people for this on solar system, galaxy evolution was one. And so, you know, I was thinking about having a few science speakers to like, and then to kind of talk about also where the opportunities are for Keck. We are a 10 meter telescope, thinking about the 2020s. You know, James Webb is launching. Larger telescopes are on the horizon. Maybe, you know, we'll have to see exactly when they show up, but 2020s is, I think, going to be still time for Keck to make hay.
Yeah, I think, Tom, if you go back to your form for a second, I would have something that's also sort of a punch list, you know, where instead of just a long answer for the capabilities, I would actually have people put in some quantitative things. You know, like, you know, what wavelengths do you care about? Because there's a big difference between JHK and L&M, and I think being able to sort on things like that would be helpful. Again, resolution, are you, you know, 100, 1,000, 50,000, or 100,000? You know, and again, you know, some of your options on, you know, what slit size do you need, what field size, AO, and so on. I would have, you know, actual options in there so that we can then start grouping them. I mean, we may well find that all the extragalactic people, all they care about is JHK, and it's really only the disk people and Mike who care about 3 and 5, with very different requirements on the resolution. So being able to project those responses into a couple of two-dimensional plots, maybe a three-dimensional plot, would be valuable.
Yeah, good point. So in addition to priorities, maybe we need to have like multiple choice or short answer for these.
Yeah, I would just have a different, you know, where you say long answer, it's fine to have that, but I would just have something like, you know, you really get to put in, you know, for wavelength range, do you want JHK, JHKLM, LNM, you know, things like that, where we can actually parse them as you know, simple to analyze data.
All right.
I mean, well, first of all, this is great, Tom, that you're organizing this. I think it's good to collect all these thoughts. One comment that I had is that it would also good to discuss, or also people can put an input about what instruments they see as a template. For example, some people like Quaris Plus as a template that we can try to, or some people like iShell. So, I mean, we should also think, you know, beyond the Keck thing, but what are the telescope, what are the instruments beyond in the community out there that we look as a good prototype that we can build on, and we can also talk about that.
Good. Yeah, thank you, Geronimo. And thank you also for tuning in because you're on another continent and it's very late, right?
Yes, it is.
Yeah, thanks for tuning in. So then, yeah, I thought about that. It looks like I didn't really make it into here, but allow other observatory instruments, which, kind of did give us impetus for some of the current instruments. It's like Muse, I think, inspired um, our KCWI, etc. All right. So
Yeah. Then I think also just something about, the competitive landscape. What do they see as the biggest competition? 3 to 5, it's JWST. At a bunch of wavelengths, certainly JHK, it's going to be initially EELT and so on. And what is our niche? I think getting people to talk a little bit about that in advance would again give us some ideas.
very good. All right, I think that's been very helpful. I'd like to move on a little bit here. We have some time at the end to discuss things a little more. So these are the instruments we all know and love for infrared spectroscopists at Keck. Yeah. I'll embiggen it here. So Osiris is AO on Keck 1. Mossfire is multi-object and long slit. Very high throughput. I've just been really impressed with like the better signal to noise I get with Mossfire than in low res mode on NIRSpec. NIRSpec's very versatile. It's also more than old enough to vote. It's probably old enough to drink. I don't know if it's been on quite for 21 years, but I know it's
You're always old enough to drink.
Oh, good point. Yeah, particularly what depends on what society you're in. And then it's, seeing limited or AO. And then recently there's been an upgrade. We heard about using the fiber injection unit, the KPIC. Jason Wang gave a good talk on that. Able to inject a fiber for point sources, high contrast. And NIRES showed up a couple years ago with a very broad spectral range at moderate resolution of about 3000. And then we have new concepts as well. The first three here, high spec, scales, and Liger, are pretty much finished designs. I think we've heard about them in other parts of this meeting so far, and pretty well developed. Keck has supported these. The PIs have been good, also getting other support, and they are, they're ready. They're shovel ready. Just send the money and they will be built. So high spec is AO fiber fed single object spectrograph. Scales is adaptive optics integral field for LNM, KLNM. Then Liger is going to be a very general purpose AO integral field spectrograph and imager. We just heard Shelley give a talk on that. And Ignis is a concept. So it's a little different category. It's not quite as far along in the designs. It's earlier. And this uses silicon immersion gratings, which were, I guess, used at iShell on the IRTF and also IGRIN's Texas instrument. And this allows to get high spectral resolution with small size, hence small cost. And it's in year 2 of a concept study. And its design is still a little open. We'll hear from all the PIs next in talking about these designs. So I think each of these has a slide. So why don't we defer to people who actually know about these instruments. So Dimitri, do you want to tell us a little more about high spec?
Excuse me one sec, Tom. I think on your table back there, I would add either in status or something, what, the cost bracket these instruments are, because there's quite a spread there that would be useful for people to as we think about these going forward.
Okay.
Or the MSIPs, MRIs,
Do you
whatever.
want that? If you're looking just for science slowdown, why would you want that? I can understand that for like an SSC level or board level, but
I think it's a matter of You know, if it's really an MSIP, you know, there's going to be one of those in a 5 to 10 year period. If it's an MRI, you know, you can imagine getting one of those every couple of years. So I think, is this giving an idea of the scale?
Oh, I'm sorry. You meant to put the NSF proposal route? I guess I was
Something
just,
like that, or just, you know, some
okay.
sort of rough idea so that people know, you know, if they're going to put their chips down, you know, what's their expected return and what's the cost.
Right. I was like, one of my comments on the Google form was that in the instrument selection, you can only choose one, which does sound like I'm putting it on a roulette table, so to speak, like you're saying, Jazz. But it'd be nice. Sometimes you want to put money in multiple instruments. So you might make it where people could select more than one.
Yeah, actually, Shelley, I think I changed it. And
Okay.
now you should be able to select more than one. They're checkboxes, at least for the current science, but and also for the new ones too. I think I just did that yesterday.
Oh, great. Thanks.
So thanks. Okay, yeah, so if we could move on, and Dimitri, do you want to tell us a little bit about HiSpec and its status?
Sure. Thanks, Tom. Can you hear me?
Yes.
So HiSpec is a AO-fed high-res spectrograph covering the Y to K band range in one shot. It's using a pretty innovative architecture. So we are feeding the spectrograph with single mode fibers, which allow us to design a diffraction limited spectrograph that is very compact and so quite cheap with everywhere else considered. So the fiber feed has been recently demonstrated or resurrected, I should say, because feeding into single mode fibers is not new at Keck. It was done before for the interferometer. But now we build a new fiber injection unit that we operate with the NurSpec instrument, which is less than ideal because NurSpec was never designed to be fiber fed. So we have to use some tricks, which are pretty lossy. So HiSpec would be designed from the ground up to be fed with these single mode fibers. And so that really allows for a very stable, cost-effective design and reach the 100,000 resolution pretty easily. The instrumental stability, of course, is enabled by the fact that we are very compact and easy to stabilize in temperature. So that makes this instrument very amenable to Doppler measurements, which include precision RV, but also pretty much all the other high resolution science cases in exoplanet science. So transit spectroscopy, which requires very stable line spread functions and very high spectral resolution, and direct spectroscopy of directly imaged companions, including giant exoplanets, as we've heard this morning from Jason, but also low mass companions such as Born dwarfs. So this instrument being diffraction limited behind AO would be very good for crowded fields and closed binaries. So we could target individual components very easily, and confusion would be minimal. So the point source sensitivity of HiSpec is 14 to 15 magnitude at SNR 30 per resolution element in 1 hour. The calibration is going to be provided by a wavelength étalon and a laser frequency comb. The instrument will have 3 modes, one single object maximum efficiency mode using photonic lantern to try to collect as much light as we can behind AO. High contrast off-axis mode to implement this high dispersion chronographic technique we've heard about this morning. And then a new mode that we call high contrast on-axis, implementing a technique reminiscent of the Bracewell nulling interferometer, which allows us to detect and characterize companions that are at or within the diffraction limit. And so an instrument of that kind would be new to Keck, exploring a new regime, and so would also be very attractive for a series of science cases spanning star and planet formation, solar system studies, stellar astrophysics, galactic center, etc. But really, I want to stress here that our main focus is exoplanet science, and we basically cover the needs of a very large fraction of the exoplanet community, from transit spectroscopy to PRV in the infrared and direct high contrast spectroscopy as well. So maybe a few words about the status of the instrument. So the design is fairly advanced. We are now starting to write the proposal that we are hoping to submit in January. So that will be to the NSF MRI program.
All right, thank you, Dimitri. Let's move on here to, oops, too many buttons. Scales. Andy, do you want to tell us about scales?
Sure. So scales is a thermal infrared instrument going from 2 to 5 microns. And it can do a lot of NERC2 science, but with the benefit of integral field spectroscopy. And in fact, if you look through the types of papers that NERC2 is publishing these days, it's a lot of exoplanet work, it's a lot of solar system work. And in most cases, if you had a reasonably small field of view, scales would be able to do the same thing, but also give you the wavelength information. So on the right, I have a couple examples of that. There's the HR-799 planetary system, and that's a simulated AILS data cube scanning through wavelengths. And then on the bottom is Io, the moon of Jupiter, scanning through wavelengths from 2 to 5 microns so that you can get the black body temperatures of the volcano. There are a couple reasons why this is the right instrument for exoplanets. So a lot of exoplanets have been discovered in the thermal infrared, but then when people went and built sort of specialized instruments for detecting exoplanets, they did 1 to 2 micron integral field spectrographs. And the combination is really the best solution for detecting exoplanets because the exoplanets peak in brightness at the longer wavelengths. But at the same time, integral field spectroscopy gives you a couple magnitudes of improvement in sensitivity because of some tricks you can play in the data reduction. So compared to NERC2, which has found, a decent fraction of the world's directly imaged exoplanets, this instrument would be 1 to 3 magnitudes more sensitive depending on the temperature of the exoplanet. The other thing that's new about this compared to other exoplanet imaging instruments is it's an optimized high contrast imager that works at R of 5,000. So most of them work at R of 100, and that's one of the regimes that's one of the modes that we'll have, but we'll also have a higher resolution mode of R of 5,000, where you're getting both the continuum that you would have gotten with the low resolution spectroscopy, but also the individual lines. And OSIRIS has been successful in doing that kind of science with Keck, but here we're going out to longer wavelengths where you can see colder exoplanets, different lines, and also you're doing it behind a coronagraph with a really optimized system. So I put in a table of specs, which you can feel free to peruse. There are 5 low resolution modes, and there are 3 medium resolution modes. The field of view changes when you go between those. So a small field of view with the low resolution mode and a smaller field of view with the medium resolution mode. And that's sort of the trade-off that you're making and able to get the wavelength information while doing the NERC2 type science. The sensitivity is pretty close to NERC2 sensitivity. It's a pretty high throughput instrument. And so that also means that a lot of that NERC2 science you could do with scales, but with the addition of wavelength information.
And what's the proposal status, Andy?
Yeah, so we're in between a couple things. So right now we're maybe midway through our preliminary design. But the other thing that we're doing, we have some funding to do this, a risk reduction phase. And so we've actually already started building real components of the instrument. Like right now as we speak, the coronagraph slide is being built and tested in a doer on campus. And so it's sort of a not so traditional way of building an instrument, but it allows us to bring in the right members of the group at the right time.
Okay, thank you. Let's move on to LIGO. So Shelley, please tell us about LIGO.
Yeah, so
You already did.
I guess I just did. I should have put the, looking at both Dimitri's and Andy's nice, kind of table of modes. I can obviously send that. We have one similar. This is a replacement to OSIRIS, but one thing I really want to highlight is that all of the modes for OSIRIS use the single fixed grading. And the modes here are using the first order. So all the gradings are much easier to design than the OSIRIS grading. We had to do an OSIRIS grading upgrade twice, which I was part of MPI of. But So we have the lenslet array here, which goes to 15 to 35 milliarc seconds pixels. So we have a diffraction limited mode. We use lenslets because we want to preserve the wavefront error right at your spatial sampling of that, and then allow the spectrograph to take over from there. So lenslets are fantastic for diffraction limited observations, and this was recognized by the IRIS team early on. And so we have the lenslet mode, which does this 2 by 2 arc seconds to 4 by 4 arc second field of view at those spatial samplings. And then we can have those pickoff mirrors happen right at the detector, kind of like the image is showing here where the imager is. And then you could select the slicer field of view. And this is a brand new mode for Keck, right? So these are getting to the coarse spatial sampling, 75 to 150 milliarc second spaxels. Just a little history here. The OSIRIS 100 milliarc second spaxel mode was a late addition. It was literally just added on after the design. And it has oversized pupils, which meant that our PSFs of our spectra blend more. So it actually adds a lot more noise when you do your deconvolution routine that generates your cube. So you'll get a huge sensitivity performance gain in the coarsest scales between OSIRIS at 100 milliarc seconds to the coarsest spatial sampling, which is the slicer here. And you get these very large fields of view up to 7 by 13 arc seconds field of view for the slicer. That's really afforded by using the Hawaii 4RG. And as I said, the other thing to highlight for modes is R of 8,000 will probably have 2 R of 10,000 gratings at H and K as well. There's some science trade studies that the Tucker's team has been doing now to optimize, between R of 8K to 10K on this. And then we do have this parafocal imager that is going along for the ride. And so that imager feeds in sequentially. It's actually literally part of the instrument. And then the other thing, just so people are aware, the short wavelength, goes below 1 micron. For the kappa performance, we will gain for field coverage. So, but if you want to get better performances below 1 micron, this is really advantageous if we look at future AO upgrades. So if we wanted to upgrade the deformable mirror in the future. And so we want to push this to keep this forward as we move along and continue to improve the AO system, and especially get to this kind of holy grail area, which we've talked about for over a decade, which is getting closer to the diffraction limit and higher strels at the red end of optical.
All right, thank you. And then can you say a few words about just where the instrument development proposal?
Yeah, so this is a couple things. One is, I would say the imager is in its preliminary design review, but the spectrograph we've tried to not change it at all. And it's essentially a final design where some even phases are ready for FAD. And so we have kind of this hybrid of preliminary design with final design. And we hope for that review to occur in March of 2021. We're funded through that, all that design until April. And we're aiming to put in a proposal, an expected call NSF proposal for the MSRI-R2. Wait, NSF keeps getting more creative with these things, but it's the mid-scale research instrument program R2. So it's the high level new funding call profile that started essentially last year from the NSF Big 10 ideas.
Right, and then so the MSRI-2, those are actual build proposals, right? And do you know when they might be due?
Yeah, so the call, because we're waiting for this, the call is anticipated to come out in a few months with a due date around February and March of 2021. And that's for phase 1 proposals.
Okay.
And this is just from conversations with people at NSF, but nothing is for certain.
Great, thank you. Okay, let's go on to Ignis, and Emily Martin will tell us about it.
Yeah, so Ignis is an instrument concept. We've gone through 2 preliminary rounds of applying to the SSC to bring this idea forward as a potential NIRSpec replacement. And basically this was born out of the technology that is going into building, or that built iGrins, which is currently on Gemini, the same kind of immersion gratings that are used in iShell, and then the same kind of immersion gratings that will be used in GMT NIRS. And the idea is that because you have a silicon immersion grating, you could actually get much higher dispersion in a much smaller volume of space. And so you can actually fit a really complex instrument into a smaller total volume and also lower costs for all of the other optics. And so this would be our original proposed idea, is that this would be a simultaneous 1 to 5 micron R45,000 seeing limited spectrograph, with the idea that we could also look at an AO fed option. And based off of some early simulations that we ran, it looks like Ignis would beat out NIRSpec by about 2 magnitudes of sensitivity, while also gaining you the full wavelength coverage. So instead of only getting 1 band at a time, you're going to get the full 1 to 5 microns in one shot. This does mean more detectors, so you'd have to, the cost of the instrument will go up a little bit from that. But we are able to leverage the instrument design that was created for GMT NIRS, in which they are also going to build early for Magellan. That instrument is called Magnifies. So that's the instrument design that is shown on the bottom left. The L&M bands are basically, you won't see an improvement in terms of throughput or sensitivity just because of the background limit. But if we were to leverage an adaptive secondary mirror like Phil Hins is hoping to put onto Keck, that would show significant gains in sensitivity in those bands. So yeah, we're still in the concept phase, but we're hoping to move forward with looking at an MSIP in a couple of years. So.
Oh, excuse me, are you also considering germanium?
Not at this time. So we're leveraging the fact that the silicon immersion gratings have already gone through many, many levels of testing and are shown to be working really well inside other instruments. I know that germanium is a material that people are looking into, but as far as I know, that development isn't as far along.
Well, that's true, but on the other hand, the index of refraction is a good deal higher, so you gain advantage in size and so on. Spatial dimensions are going to be smaller for the instrument, etc.
Yeah.
Then the other question that comes up immediately is with 5 bands covered, JHK, L, and M. You're going to need, as you show individual detector packages for each one, but the reality is that I times on-chip integration times for the M band and L band are going to vary significantly relative to JHK. So it suggests that there's complexity in the electronics, data acquisition, I time, and so on. I don't know if you thought about that.
Yeah, and that has all been already under works for the GMT NIRS instrument and for Magnifies. And, we can clock the detectors at different rates. And it's more, the idea is that you're going to be getting, if you're trying to take observations in the J band, you get H and K for free pretty much. And maybe the L and M band are less useful to you. But if you're trying to take observations in the L and M band, you can get the full 3 to 5 microns and also get the near infrared kind of for free. But clocking the detectors at different rates is not an issue.
Yeah, hi Emily, it's Chaz.
Hey, Chaz.
One of the things when we discussed this at the SSC is, it's really a plethora of arrays. Are these 2 RGs or 4 RGs?
These are 2 RGs.
Yeah, so one of the things we were talking about is whether, a slightly simpler design that, put a JHK onto a single 4 RG might make sense, and then a second one to do L and M. I think people were just struck by, you either going to, typically the science cases are you really want to do a bang up job at JHK or at L and M. And, just trying to simplify things a bit to just use 2 4 RGs might be a way to bring down the cost and complexity.
It's not clear that would actually bring down the cost given the current status of the development of the 4 RGs, but
5 years in the future, I bet it does. I mean, there's a lot of optics in there now.
Yeah, but the other nice thing about condensing the number of condensing everything into separate bands, part of the problem with the throughput on NIRSpec is that you're having to do these very wide codings that are that work across the full 1 to 5 microns. And if we can get a cross disperser that works specifically, is like optimized for the J band, a cross disperser that's optimized for the M band, you can actually really gain in throughput.
Okay, well, I think it's definitely worth quantifying those arguments.
Yeah.
But I'm just relaying that you know, the pundits on the SSC, without thinking about it, that was their reaction. So I think you're going to want to have some arguments that allow you to say, no, as usual, you pundits are wrong and this is the right answer.
All right, thanks,
Yeah,
Jess.
and
Just
I
to add
think
on,
the
there are no
SSC
moving.
SSC did give Emily that feedback in the letter too. So
Yeah.
so there, she and Greg are working on that. I trust.
The other thing to add is there are no moving parts. So it's, you know, you add a few more detectors, but other parts of the instrument are much more simple to design.
And much more stable, which is another problem with NERSPEC. So
Yeah, and I see these nice compact refractive cameras that you're not going to have if you go to multiple, you know, coverage on a 4RG, right?
exactly.
Okay.
Emily, this is Geronimo. So this is nice. I actually like a lot this concept, especially I like this spectral region. So one of the things as a planetary scientist, I like to have long slits, and you know, NERSPEC, even though is, you know, old and everything, but it does provide longer slits. And have you? And I know when they developed an iShell, they went through a lot of hassle trying to match, you know, the different science cases to get longer slits. Have you thought about it? How difficult or easy it is to do this?
So the current slit design is a 4 arcsecond slit, and yeah, I think that's something that actually could really be helpful coming from this workshop, would be learning about the different science cases and what slit lengths would be required. I do know that the planetary folks want longer slits, but sort of maybe a trade study between different slit lengths and modes. But if we want to be able to fit an entire band onto a detector, there is, at that resolving power, there is a trade-off there between slit length and resolving power, effectively.
All right. Thank you, Emily. Thank you for a good job of responding to all that feedback. As you can see where the SSC's letter came from. So I think we've got a little over half an hour. So I thought it'd be good to go over, have a discussion about the workshop. Also, we do have over 30 participants here, and if I think it's good to have a free-form discussion. If you're having problems getting comments in, please use the Slack breakout page. We have a breakout channel for this session, and encourage people to put in comments and questions there. That way, you know, we'll also be able to easily get a record of this. So first off, you know, date. There was a question about date. Do people think that late October is going to work? Is that too soon? Would be interested. If we did that, we'd have to get a survey out pretty soon to the community, probably you know, next week or something like that. So anybody with
I just had a
concerns,
question.
please speak up.
I had a question about, I think someone had asked it at the beginning, which is like, what are the number of people you're hoping for? What's the audience? I think Chaz broke down in subject headers titles, which was great. But we're living in a pandemic and it's pretty crazy around here. So I'm just worried about everyone's bandwidth, and 3 weeks is like tomorrow kind of. So
yeah, that's a good point. I would like to get input from a broad swath. And I think that maybe putting together a good survey and getting a good response is going to be important. And then I see the workshop as trying to digest some of that and putting that onto the instrument. So maybe, yeah, 4 weeks is going to be too close for that.
Yeah, you might also want to split the meeting, not one full day.
Okay.
It's pretty agonizing.
Yeah, well, let's figure out
2 half days, something like that.
Okay, yeah, let's figure out what the content should be and if it makes sense to break it up. Yeah, we should also respect time zones. You know, people are from Hawaii are going to participate. You don't want to start too early. People on the East Coast, you don't want to go too late. And also, you know, we just don't want to like Zoom ourselves to death, right? Which we all do.
There's also overlap with DPS potentially. So.
Yep.
Okay, Mike. And when is DPS?
Let's see. When was it, Sarah? I think you.
Yeah, it's 26th, 30th of October. It's virtual, but yeah, it's gonna be pretty much full days.
Yes, so and then so that's fourth week of October, with talks and posters being available for viewing the week before. So that's the third week.
Mm-hmm.
Another problem with the third week of October is you'll lose a lot of the Keck community, I think, because that's the TAC, I believe.
Okay, so that's like most of the TACs are going to be meeting then, UC, Caltech, NASA.
I don't, yeah, I'm sorry, I think, yes, I know, I'm pretty sure at the NASA Keck Tech, I don't know about the others.
Yeah, I can check on the dates, Tom. For me, I agree with Shelley that I think it's better to have robust online discussions and iterations so that we sharpen before the workshop what the issues are, and then have the workshop sometime in November, even December, just to give us a break. I feel with the fire at Lick, I feel just totally stressed out right now.
Yeah, I can see that, Claire. And this actually has evolved into something bigger than I originally thought. You know, just in discussing it with the SSC chairs, I realized, oh yeah, we need to consider upgrades. Oh yeah, we need to consider this and that. So yeah, maybe a 1 month schedule isn't realistic. Okay, so does anybody see a hard date by which this would no longer be valuable? You know, I'm thinking that after we have the, you know, if we do the poll, we get the results, we digest them, we have a workshop, maybe a couple weeks for a report, and do the instrument PIs. I mean, I think that you know, this stuff might be most useful, the input to instruments that are not fully developed already, you know, like Ignis or other ideas, and was sort of wondering if anybody sees like a need date for this by which, you know, we should definitely try to get the output by.
Well, what is our spring SSC? I mean, being able to present this at an SSC meeting to me makes sense.
There's a November 11th, 12th one, but that's not soon enough.
That seems too early, it seems to me.
Yeah, and that's we spent a lot of time on like at Keck and the Keck status and all that. So yeah, I agree that the spring one could be good. I don't know, but it's usually like February or March, right?
Yeah, I can check. Hang on.
I'm trying to check now.
Oh, it looks like March 10th is what I have.
You know, strategically, Tom, does it get to questions on, you know, the instruments that are going to be proposing for and needs? What would be really nice through this process is to get more national participation and people within outside of the Keck community scientifically excited about these instruments. I think that's strategic for many reasons. And it's something that would help, I think, help all of the programs here. But
yeah,
but that just adds more time and work to it.
Yeah, then we need to then separate out surveying people's needs, which, I mean, do you think, I mean, I was thinking just Keck community people, because if we're going to be, you know, if we're going to write a strategic plan, we want to know what our community does and have instruments responsive. I take your point that it's good to get everybody involved in, you know, understanding what's going forward.
I agree with Shelley in that it seems to be one of the problems of getting NSF funding for Keck instruments is showing that this is going to be, that the instruments are going to be broadly available to a larger community because the NSF represents the country as a whole. And so it seems like getting broader community interest is a good idea.
Yeah, I think we'd certainly want, maybe it's by invitation, to bring in, you know, a couple of people representing, you know, some of, you know, one or two people from Noir Labs or Space Telescope or JW, or just, you know, so that it does reflect a broad community input. Obviously, the survey will help with that, but I think we should have some people from the outside.
Magellan, VLT, just so we know what the rest of the world is doing.
Yeah, definitely.
Do we have a list of the top users of Koa? Is there like a Keck, do we have any statistics on Koa access?
Chaz, would you have that info?
I mean, we certainly have, you know, we track the papers that mention Koa as part of their acknowledgements. So we could look to see, you know, if they're hardcore users, you know. I mean, there's this one guy, where was he? Used to be at New Hampshire. Oh yeah, John O'Mara. was a big user. You know, so I'm not sure if there's, you know, there are people who are, you know, multiple users with, you know, large numbers of papers. We could certainly look at it, but we do track it.
All right. Yeah, we need to also think about, you know, keeping this thing a finite size so it could actually get done. And maybe some bigger questions here. I think they're all good, and we should consider them maybe for other activities. You know, like Koa in general. You know, and the whole bigger problem of getting the greater community more engaged and supportive of Keck. I think that I'm very happy to try to do that within this context of infrared spectroscopy. But
yeah, I think, Tom, in your, you know, your initial survey form, maybe put a demographic question. You know, are you inside Kara? You know, where, you know, just some institutional information, and then also, would you be willing to participate in a one-day workshop?
Yeah, I've got that one. I do have a little demographics, but that's a good point about adding. I do ask institution, but the point of inside or outside of Kara. So that gets into this next item. So it sounds like maybe December or January could be the time for something like this. And it sounds like it's more, sounds like I'm hearing it's going to be more important to get the survey right and to get good input and to help shape the meeting. And it's more important than rushing something and getting a product. Is there some consensus agreement or objections to that synopsis?
Actually, a little concerned. It seems to me, this is Mike, it seems to me that one should work backwards from the due date for proposals for instrument support at NSF. And from there, go backwards to SSC approval and consideration, move backwards some more towards initial workshop leading to instrument definition concepts that are improved and so on and so on. So really have to think through I believe, the timeline for those things, and that will lead you to an intelligent choice of when the first workshop must happen.
Yeah, I think just being able to report to the spring SSC, which is March, you know, back up, you know, to January to have the meeting, a month or so to write up a report, and then you're in good shape to go to the SSC.
But you still have to have each of the 4 instrument teams prepared to mature their concept while the SSC is considering the recommendations from the workshop, such that they will be ready to propose to NSF if the plan is to do that next year. And so
I think the instrument teams, the 3 that are already approved for full proposals, are pretty well defined. They've got their own science teams. I would think that what you'd be getting out of this would be somewhat peripheral. You know, hopefully you'll add some additional support. The workshop itself that's where we can maybe expose more of the community to what these concepts can do, and then that will happen before the review. So do you instrument PIs agree that maybe it's not so important to have this workshop itself before your proposals go in, or is that not right?
I think that's correct, Tom. We do all have our, you know, developed science teams and have moved forward already for this. Maybe one nice thing to do, you know, just in your thinking about ways this could help existing proposals about to go in. There are things that I'm interested in hearing back from the community. So maybe each of the PIs could write up a little summary of what they would hope to get out of something like this.
That's a great
one of the things that I would like to tap in more is LSST and spectroscopic follow-up. And I think that was my interesting comment about trying to get to the broader national community for that.
All right. So I put the link here for that survey that I showed briefly. I'd really appreciate comments on this. It's probably not worth filling out at this point because it's going to change as I've already done to Shelley, I think, you know, and but it'd be most useful if people could take a hard look at that. I'd really appreciate if you could send me comments, and I will put my email address in.
Could you put the link in the chat? Because it's.
Yes, yeah. Let me do that.
Yeah, Tom, one other thing you might also add is to put a NASA spin on it. What NASA missions do they envision this supporting? Both astrophysics and solar system. Is it Roman? Is it JW? Is it HABEX, LUVOIR,
Guys,
New Horizons?
Are you asking this of the instrument team, or are you asking this of individuals filling out a survey for generic spectroscopy?
The individuals, what does their science case say? Hey, this will really help me getting redshifts for, Roman telescope deep field number 3. Or it complements JW with the short wavelength with my longer wavelength stuff coming from JW. And I think, that'll emphasize, if nothing else, to NASA that we're very explicitly taking, the mission support aspect seriously. Both solar system, and astrophysics. Yeah, so it's a question of the survey people.
All right, there's a link to the survey document there in the chat.
Tom, I don't know if this is easy to collect, but I was thinking that at least when the people fill the form, they can also provide ideas about participants outside of the classical Keck observers that we can invite. I don't know, thinking about, I will probably tell you, okay, we can invite John Rayner, for example, or someone like that. And I think all of us know someone who could be also a good person to have in the workshop to provide feedback. So I don't know how easy it will be that to collect, but there may be something that we can ask to in the form.
Okay, and ask for suggestions of other interested people. Thank you, that's a good one. And I like Shelley's idea too of having people, instrument PIs and other, to send comments about what you'd like to get out of this workshop. So, and that could help us also edit the form. Then, so for the workshop, let's see, where's that here? Okay, content. So we've already talked about maybe having some short science talks for the workshop to kind of digest some of the input from the survey and give just some more analytical results from the survey. Some information about what's the current instruments and what's planned, to figure out how to do that in a way that is not going to take up a lot of time for a big group. Maybe make a lot of information available beforehand. And but I think it's going to be important to have a discussion about what opportunities there are. Particularly, for upgrades, for new things that aren't getting done, for bringing in other communities. And because that's really, I think, going to be a lot of the basis of the report. Are there chunks of science that our community wants to do or other communities do and we can't, that we don't have the capabilities for? That's the sort of thing that I think that would be really good to come out of this. And to take the points made so far, we should mostly have the Keck community members with some invitations for people that are really tied into other communities, because you have to know your competition, and also that we've had good luck in kind of sharing ideas with different communities, and this can only help us. We appear to be. We all know that. Keck has, got the greatest facilities, and we also need to make sure we do the best science by getting as much input.
Hey, Tom,
Okay.
Can I ask a question?
Sure.
It's Randy. I'm curious, with SPIE open to all and free in January, if that's something you might want to leverage somehow for this, especially in the context of the broader community, and to see what others are doing.
Good point. I'll have to see. I know their deadlines are usually way in advance. I'll have to see if they've already passed or not, but I'll look into that. To at least have a session about maybe current and planned instruments for Keck. I don't know how much you want to give away with the instrument PIs want to give away with their plans. I think most of these are pretty well known in the community, and you've been building that, so we should maybe have a discussion into that. Keck IR spec instruments. Okay. So I think that the most, I was a little, got a little ahead of myself. You can forget that doodle poll for when to have a workshop. I think that the most important thing that I'm hearing here is we need to figure out what we're going to get out of the workshop and get the survey right. Right now, it's just a science survey, or primarily a science survey. We should figure out whether we can get all of our needs met with this, or whether we even want to have another form. And then we do need to eventually think about the broad agenda. We talked about, also mentioned in the last slide, to have those science speakers and some interpretation of the survey results, and do an assessment of where gaps are between what people want and what we have and are going to get, and that would be scientifically worthwhile. And then we'll rely on all of you to do a lot of promotion once we get this sorted out. So we're going to need to promote the survey. John Amira agreed to send it out to the whole list of people that got announcements for the Keck Science Meeting, and it would be great if our individual sub-communities could sort of make sure that interested people respond. And then also individuals to sort of announce both the survey and the meeting once we get that. So I guess that one of the things that would be most useful now, again, would be to comment on that survey form and send in goals for what you think the session should have. So I'm going to write that in our Slack breakout session. And anybody else should also feel free to put comments in here too. I think they may be more useful than just the chat of the, of this. So I don't have my computer skills down very well. Might be more useful than just the chat for this Zoom meeting.
Hey, Tom, just from Google form experience with TMT and ISDTs and trying to corral hundreds of people to fill out a form. Mm-hmm. Maybe going by Chaz's suggestion of breaking up science area, you might need somebody to go chase down people to fill out forms. Like I've found over the years with TMT stuff, it takes a personal email to get someone to fill something out.
Yeah, I have already, I agree with that, Shelley, and actually I've already bugged a few key people about the workshop itself that way. And yeah, I realize that's what it's going to take. So I'm going to write some, it's going to be writing here, be helpful if attendees could comment on the science survey form and the workshop goals. And I've got the, I'll put the draft survey form.
Yeah, I think one thing to highlight is that this is really meant to be a strategic planning exercise rather than tactical. We sort of see this fitting into and leading up into the new Keck strategic plan. Mm-hmm. So this is laying groundwork. We will probably have to pay, some homage to the decadal survey. We'll be a level down from that level of strategy. But I think this is really something that leads into the Keck strategic planning activity. In the sense that it's like the National Academy Exoplanet Strategy Report really will feed into Astro 2020's exoplanet recommendations is certainly, what we've been hearing. this will feed into our Keck strategic planning, and we're just getting a head start. You know, you could actually imagine the SSC commissioning a couple of these, you know, future of Keck for wide field imaging, or, whatever other big areas of strategic thinking ought to be, will be, a step ahead as befits the importance of our science.
Right. And maybe the next step in time domain could be another thing for us.
Yeah.
Yeah.
So I think this will be a model for a number of things going forward.
Yeah, and it won't be perfect. And,
yeah.
But hopefully it'll be useful.
Yeah. And I think maybe discussing it with John in the context of this is something that will feed into the strategic planning. He may have some spin on that he'd like to make sure is injected.
Yeah, and I should probably bring the SSC co-chairs in on that too.
Yeah. Because I know we haven't started really thinking about that yet, but because in fact we're waiting for the decadal before we really kick that off.
Yeah, I was talking to one of the co-chairs the other day, and we're figuring out, and I said, well, we're going to need this next strategic plan, and we're both going, well, when's that going to happen? And then, we just started counting, and it's, nominally next year.
Yeah.
Yeah, so Tom and Chaz, could you please comment on something? It seems to me that these four concepts most surely have been developed with strategy in mind in the context of the planned instrument complement and the 30-meter class telescopes, which are coming online at about the same time. And so what do we know about that? Has that indeed been a consideration, or has this been just a Keck-only consideration without any strategic aspects regarding external facilities?
I could say a few words from my perspective in that these have, so the first, whoops, I'm moving my mouse seems to move my screen. So the first three here, these are the ones that are have pretty solid developed designs ready to go for build proposals. These have all been influenced by other observatories. HiSpec and Liger sort of directly came out of TMT instruments. And I think that the PIs here, you could please pipe up, realize that there's a great opportunity for Keck to do something like this. And there's been need for these things on Keck. And Scales leverages, what's been done with Arizona telescopes. Anybody else want to comment on that?
Well, certainly Ignis grows out of the current NIRSpec concept and addresses a number of issues that were not yet addressed with NIRSpec 2. So in a sense is internally strategic for sure. And I think the other things are too, but I was asking more about Keck as a competitor for other facilities and the long-term strategic view for these classes of instruments.
I think of these, Liger is really the most general purpose. And I don't know, Shelley, do you want to comment on that?
Sure, the truth is we'll be there before there are ELTs. So there's not a first light. The only first light complement obviously would be the ELT harmony. And there is, the difference would be wavelength coverage and spectral resolving power for this, and including field of view. So I could add that to, those A10 color options for it. But in terms of timing, this comes before, and there's definitely a niche here. It should not escape us that the top three here that are moving forward, right, for the NSF proposal, and even the conceptual designs of Ignis, are wanting to go use the adaptive optics system at Keck, right? So these are AO-fed instrumentation programs, and that really is a niche for Keck. Comparatively to the other facilities.
And I can also comment that some of these decisions come from during the discussions during the Keck SEC, and one of the things that we look in the committee is that the usage about other instruments, the current set of instruments, and that defines more or less the pressure on what are the instruments that provide. And then that also guide some of the decisions. They are not, because we cannot base everything on the past, but they also are elements that we use in the decisions on this.
I actually have a question, probably for Emily, but with Ignis being at least perceived as a replacement for NIRSpec, does that mean that the NIRSpec optics, that there's no plan to upgrade that to say get higher resolving power, spectral resolving power? I'm just curious.
Yeah, I mean, that's my understanding, that there's no more planned upgrades for NIRSpec. And, the optics themselves are already diffraction limited. We replaced the detector, but there's a lot of parts inside of NIRSpec that are very old and have already broken and will probably break again. That's the part of the problem with having cryogenic moving parts. So yeah, we saw Ignis as a way to replace NIRSpec with something that would give you higher spectral resolution and broader wavelength coverage at the same time.
And better sensitivity.
And better sensitivity, and also no moving parts. So basically just like winning across the board.
Well, for planetary, I mean, as people have alluded to, spatial coverage is, that trade-off obviously would have to be, addressed too, whatever can be done. But thanks.
Yeah, definitely. And I think it would be good to talk offline with more of the planetary community as well. So.
Well, this is great. I'm already happy to see that there's already some science discussion between users and the instrument developers. Does anybody else see a need to cover anything else? I think, we made the points that I've gotten the message that it's probably more important to do the survey right, pick the focus of the meeting. Would very much appreciate input from everybody on that. And I put a little information in our Slack breakouts, because I think that's going to be sort of the enduring record for this session, such as it is. And I'd be happy to hear from everybody here on those or other related issues.
I have one last question. This is Leslie. So you listed cutting across different science disciplines for talks at the workshop. You might want to think also about cutting across the use of the existing near-infrared instruments, to hear NIRES versus NIRSpec users.
So yeah, can you say a little more about that? Are you thinking from technical capabilities or scientific applications, or what there?
Technical capabilities, so to hear from at least one very high spectral resolution, and at least one low or moderate spectral resolution, at least one wider field or longer slit, at least one IFU. It then gets hard, because you're trying to, again, fill in this two-dimensional matrix.
Okay. So
that's something to consider.
So are you, I'm still not sure if I'm getting it. Are you talking about just kind of charting out where the current capabilities are to see like where holes are, or is this something else?
If everybody has a very good feel for what all of the current capabilities are, then maybe this isn't needed. But yes, that's what I was thinking. Yeah,
I mean, I'm really with you there. On the SSC, I asked for a very simple thing once that just couldn't sort of be done by the Keck communities. Like compare the sensitivity of NIRES, low-res NIRSpec, and MOSFire, at the same wavelength. And yeah, there's there's a lot of stuff to be done here, and it's sometimes it's good just to get some basic information. So I'll take that point that it's good to kind of explain what we have before talking about new needs. Any other comments before we wrap up and break?
Thanks for organizing this, Tom, bringing us all together.
Oh, you're welcome. And thank you all for doing the work. 'Cause I can't do it all by myself, and looking forward to working with all of you and more people in the community. Let's do this right. I will also try to ping some individuals, but really looking forward to getting some feedback and appreciate what I have today. And you've got 6 minutes or so before we start the next session. So thanks everybody, and I'll end the call.
Thanks, Tom.
Thanks.
Thanks, Tom.
Bye.
Thank you.
Thank you.
Thanks, Tom. Thanks, Chaz.
Thanks.
Good job, Tom.